Okay. Okay, welcome back. Just waiting for a few people to join, and then we'll get going today. Correct. That's the plan, at least. I mean, I'll still be available through Discord tomorrow, should you need to ping me. But I really probably won't be at my computer most of the day, so... questions that I can answer through text, not necessarily questions that I can answer through code. Okay. All right. So, just to kind of give an agenda, I did post a few things today in the Discord, if you follow back up. So part of that, let's see, if I kind of go through what I posted up there, I posted the finished code for the example that we're going to go through today. I posted my updated slides, so pull those off of Discord. I haven't gotten a chance to update the ones on Perusal. I posted a link to the video, and then kind of a quick summary of our agenda for the next few days. So today, the plan is to go over part of the slides for 10.1. And we're not going to go over all of them because there's actually quite a bit in 10.1. So what we're going to cover is the first part that's about kind of the room database part. And then next week we'll come back and we'll talk about live data and view models and the lifecycle class, those pieces. So we're going to go through part of it today, and we'll go through part of the lab, and then we'll go through the second half of that tomorrow. Next week. Tomorrow is Good Friday, so that's... As usual, it's a school holiday, so there won't really be any, per se, class tomorrow. Again, if you should need to get a hold of me, I'll have Discord on my phone, so I'll still get notifications there. But I won't be up for calls and things like that. So any questions that I can answer on from my phone, I'll still be able to answer those. But if it's something I need to be able to sit down at my computer to answer, that'll probably have to wait till Monday. So that's what we're going to do. That's kind of where we are for today. We're going to go through the first part of this room database lecture, and then I'll do an example. I'll do part of the lab. We'll go through that example, seeing how this room database works and some of the things that it makes easier than using the SQLite, that SQL Open Helper that we used yesterday directly. I think due dates wise, I'd anticipate due dates being next Friday on Chapter 10. but I need to double check that I've updated that in Inside Rec, and it might be out of date. But that would be my anticipation. It'd be Thursday or Friday, probably Friday. So Good Friday is tomorrow, and then Monday we'll do a review finally of the last hands-on test to kind of get back up to speed with some of those things, because we haven't touched we haven't touched Volley, we haven't touched the job scheduler this week. So I want to come back and look at that on Monday, and then what we're going to do once we go through and do a code review with that, I'm going to then add in the room database and live data and the view model and all these things that we're going to talk about here into that hands-on test project, so we can see how those things work together, especially with Volley in the mix. So we have data stored in the database for kind of offline viewing, but we also have the ability to go grab it from the network. So that's what we want to do on Monday is do the code review, do the review of the hands-on test, and then Tuesday we'll build on that, and I'll go through the rest of the slides, and then Wednesday we'll finish up wherever we get to on Tuesday. We'll kind of finish that up and go through the second part of the labs and talking about live data and view model and how that fits together there. And then I think then there's maybe a little bit more that we may need to do for, because there's a 10.1a and then there's a 10.1b. And I think this will put us at the end of 10.1a, but I haven't had a chance to look at where 10.1b is yet. So that's the gist of it. I think both 10.1a and 10.1b don't have code challenges to go with them. I'd have to go back and double check. So most of the stuff that we do for 10.1 will be in class. Now, one thing to remind you of, you definitely want to take some time to get started on your second draft for your project proposal. The requirements for that are up on Inside Rankin, and the due date for that is on next Friday. So definitely get in touch with me so we can talk about what specifically you need to do for that. But basically, it's take the draft that you've already written, improvise it and improve it, and take all the comments that I've given you for your first draft, bring that in, and add some additional charts and diagrams and such. So screen mockups, entity diagrams, those kind of things I'll expect for your second draft. Is there a third? There's a second draft, and then I think the third submission is your final submission of it, which I think is about a week after that. So, I think the second draft is due on the 24th, on the 17th, and then your final version of it is due on the 24th, which puts us right kind of in the middle of working on your final project, but it should be kind of early in that process. So that's where we're at. Are there any questions more on the schedule there? Let's see if I have my due dates. What are my due dates set to? Oh yeah, the due dates are not. Due dates on Inside Rankin are definitely wrong, because they say everything's due tomorrow, which is not right. Yeah, this for me says that your lab should be due on tomorrow, but that's not up to date. So let me update those due dates here. So that puts this over to, say, the 17th. That should also be the 17th. Same thing there. All those should be the 17th. and then that puts this on the 20th. And that should be then, say, Wednesday. Yeah, so I think those due dates for Chapter 10 are up to date there now. I thought I'd gotten those all already up to date, but apparently not. So it just happens with things shifting. Okay, so let's get into lecture now that we've kind of talked about the schedule. Pull this up. So we started talking yesterday with 10.0. We started talking about SQLite and some of the nuances, some of the quirks that go into building databases with SQLite. What we then want to, I kind of went over an example of how we historically have done that with the SQLite Open Helper class. So that gives us a very kind of direct access into it using cursor objects, writing actual SQL that we then have to run. Unfortunately, that kind of leads to a lot of boilerplate and different things that we have to go through. I think the comments are working. At least they seem to be up to date. It leads to a lot of boilerplate that we typically have to write again and again, and it's not maybe as strongly typed, especially with having to write SQL directly. There's a bunch of different ways that things can kind of get out of sync. So adding in, what we're going to do today is cover the room database. The room database is going to reduce the amount of code, the amount of boilerplate that we have to write and kind of maintain to work with that SQLite database. So that's going to make it easier. The other parts in here, it also talks about the live data class and using view models and using something called a repository pattern. We'll talk about all those as we're kind of working through. I'm going to focus on just room today, and then next week we'll come back and we'll look at some of those other parts. So kind of a broad overview of everything that's in 10.1. We'll talk briefly about the architecture components. We'll talk about how to create entities. We'll talk about how to create DAOs, which is an acronym for Data Access Objects. We'll go through working with the room database. I'm going to talk a little bit about the repository today, although my example won't actually use that repository pattern. We'll come back and actually do a repository pattern with the Hands-on Test 4 project after we do the test review. So I'll go back and look at that. Same thing with live data, view model, and lifecycle. So these three things and the repository we'll really talk about next week. So first, let's talk about what are the architecture components. So the architecture components are a set of libraries that are used for structuring your apps in a way that makes them more robust, testable, and maintainable, at least if you use them properly. There's no silver bullet for any of those three things. So if you're still following bad patterns other places, or how you use them is not necessarily all that good, you're not necessarily going to see those benefits. However, that's the goal. So the architecture components is actually kind of a really big thing, relatively new thing as well in Android. There's a lot of different pieces that have been introduced as architecture components. These are all built into kind of this Jetpack project that's come out. So they're all kind of pieces of that. So one of the things that means is really to use a lot of the things here in 10.1 and on. You really do have to be running with the Jetpack dependencies to really use them properly. So that's just the thing to be aware of. There's a lot more things in terms of architecture components that are out there, and there's documentation for, but we're only going to cover kind of a small piece of that. But this is a pretty deep topic if you were to dive into it further. So as far as architecture components, there's a lot of kind of best practices in theory that's in there. There's a lot of different libraries. The idea is to encourage you to use kind of the recommended architecture. And in theory, at least, they're meant to lead to a lot less boilerplate code. At least from reading some of the stuff we're going to cover today, that may not if you've read through all of 10.1, that may not seem like it's the case. It may seem like, oh, this adds a lot of boilerplate to do this. And for simple projects, this really does. For simple projects, I'd say that I could do some of these things with less code without using all these architecture components. Where it really saves you time is as your projects get bigger. So there are certain things that, hey, if you're setting up just a very simple program, then you're not necessarily having to future-proof and deal with large numbers of activities and them having to manage state in between each other. But as your project grows in scope and size, as you add more activities, add more services, add more classes in general, you find that these architecture components do start to make things a little bit easier in terms of managing the state and in terms of cases that you have to handle. So the more activities you add, the more time this saves. It can help with testability because of separation, the kind of separation of concerns, putting things in different places. At the same time, it also leads to some additional testing problems too. So take that with a grain of salt. In theory, it's fewer dependencies, so we're not necessarily depending on specifically all the way down to SQLite and all some specifics there. In theory, it should be easier to maintain, but again, it all kind of really depends on how you build it. So depending on how you build it, you may reap those benefits, you may not reap those benefits. So a lot of this comes into like, if you use it well, if you use these architecture components the way they're meant to be used or the way they should be used, you will save yourself time and you will be able to make larger applications quicker. But if you're not using them appropriately, you're going to run into a lot more issues than you might without them. So there's also a pretty big setup overhead to get some of these up and running. So that's just something to be forewarned. The core kind of documentation of the architecture components and such, you can find at developer.android.com/arch. So that's where the main guide for all of this is. If I go follow that link, there are a few things that we'll need to look at today as we go through a practical example. Namely, in here we'll have to kind of look at how to get the latest versions, how to get the proper dependencies. Because what was originally in the code lab, what's originally in there, things have changed pretty drastically since that time. So how we actually bring in those Gradle dependencies is a little bit different. Okay. So the overall kind of architecture of how all the pieces fit together that we're going to talk about in 10.1 is like so. So we have up at the top, we have our UI, which is our activities and our fragments. They deal with actually displaying the data to the user. Our adapters also kind of fit into this this grouping. So we've got activities, fragments, and adapters. All of those are kind of part of our UI controller. They're going to deal with taking the data and displaying it to the user. And they may also respond to, say, button clicks and such. But they're kind of our front end that the user sees. And then behind that, we're going to talk about two things, which is the live data and view model classes. And they help manage kind of updates to the data. So pushing updates from the back end, as well as kind of requesting and managing the data from the front end. There's several advantages to using the view model and the live data. A lot of it has to do with, well, especially at scale, you have more activities. You're going to potentially want to show that data on more than one screen, or you potentially want to cache that data so you can refer to it later, or you can have offline access to it, as well as not having to fetch that data just because they maybe left the application and came back, and kind of managing things not just tied to a specific activity and state and such. So that's where that comes in. This is the part that we'll talk about next week, kind of how this connects. So what we're going to focus on today is really this bottom part of the diagram. So the next, kind of beneath the view model, we've got something called a repository. This is the one thing that's not really a defined class and is really something that's quote unquote optional. So at least with the example that they give, this may seem kind of, if you've read through 10.1, the repository, if you've kind of taken a close look at it, you might ask, well, do I really need that repository? You really don't have to. The place where this repository becomes helpful is when you're sometimes pulling data from the device, when you're sometimes pulling it from your cache for offline access, and sometimes you're pulling it from the internet. So that's where I want to go into kind of building out our last hands-on test with the NPR stories, caching those offline in a SQL database, and then if there's not like internet access, and then if there is internet access, then pulling that from the network. So that's where that'll come into play. The repository is really helpful when sometimes you want to pull the data from the network, sometimes you want to pull the data locally. So that's where that comes in. So again, we'll talk about kind of that top part of it more next week. So the part we want to talk about today is what's down here. So the room database is kind of this encapsulating sort of abstraction of the data that's underneath. It works a lot. It works fairly similar to how Entity Framework worked in C#. There's a lot of commonality over there. It's not exactly the same. There are definitely some things that are different. And I would say actually Room gives you a bit more control, a bit more flexibility than Entity Framework gave us. But it's also meant for other kinds of things. The way it works it makes a lot more sense in a mobile sense, especially for Android, than it might make for if you're building a website and building the backend for it. So the room database is this kind of abstraction. We'll end up using that as your pathway to the SQLite database. And rather than having to manage certain things that we had to do manually with creating the tables and migrating the tables, Room Database does know how to do some of those things out of the box for us, which is nice. Also in there, we'll talk about how to build entities. Our entities basically represent an individual table. So let's say we have 3 different tables in our database. Well, we're going to have 3 different entities. If we have 7 tables in our database, we're going to have 7 entity classes. Okay, so each of those entities represent a row in a database table. We also create DAOs. DAOs, those data access objects, are what we're going to use to interface with the actual SQLite database. It's going to be kind of our go-between between Room and the SQLite database, between entities. So a lot of what will happen with those DEOs, it'll kind of magically, we say, here's what I want to do, and it'll kind of magically wrap that up in either lists of entities or entity objects themselves. So we'll do a lot of that translation, kind of like Entity Framework did for us, where we just wrote C# code, and then we were working with C# objects rather than writing a lot of SQL code. We still write more SQL code with these DEOs with Room Database than we did in Entity Framework, but the amount of SQL that we're going to write is actually pretty small. So that's kind of where things lay out. So those DEOs are the parts that actually interface, that sort of interface with SQLite. Room Database itself interfaces with SQLite, but those are all little pieces that we have to put together in order to make it work. So the example application that we're going to create with the labs, and again, we're doing part of this today, and we're going to do another part of it next week, is we got the main activity, which is going to show a list of words, and then we'll have a new word activity, which you can go to through the little plus floating action item button, and that will add a new word and then send it back to, you can enter a new word and then send it back to the main activity, where it then gets added to the database. So that there will be an observer in here that's watching the view model and the live data to see changes when they happen. There's also an adapter in here that's kind of connected in there. Same thing, where kind of similar to what we've built before. We have adapters for your recycler view that take a list and turn it into UI objects. Same thing here. We'll have a word list after that takes a list of words and turns it into the relevant controls. Then beneath that, we have the word repository. That repository is kind of going to be the go-between between the view model and the database. That way, say you want to put in some web services, you want to push some stuff online, and you want to have maybe sometimes it's online, it's supporting offline, and sometimes it's purely offline. That's where that comes in. And then beneath that, we'll have our database. So in that database, there'll just be a single table of a single entity of words, and then we'll have a word DAO that's kind of working with that table. Okay, so that's kind of the overarching view of what we're going to do with the lab. But the things we're going to focus on is not all the stuff in between. Today is not all the stuff in between. We'll build the main activity, we'll build the new word activity, we'll build this database in between at the bottom here, but all of these classes, the observer, the live data, the view model, the repository, I'm going to push that off till next week. So we'll still connect it so it can show and insert words, but we're going to do that without all those other architecture components in the way. So to kind of give you an overview of Room, Room is designed as a kind of robust SQL object mapping library. So the idea is that it takes the tables and turns them into Java objects that we can work with, or takes our Java objects, saves them to the database, and kind of deals with a lot of those details of reading and writing data in SQL kind of transparently. So we'll generate a lot of that SQLite code that we would need to write, and ideally it's going to simplify that interface with the database a lot. So entities, we've talked about that a little bit. Entities are what's going to define the schema of the database table. So when we're working with Room, we actually don't need to write create table anywhere. You remember when in the example we did yesterday, I had a create table statement in that onCreate method of the database object. So that onCreate method did two things. It created the schema as well as inserting some data. So we'll have kind of a similar onCreate still, but instead of needing to both create the tables as well as insert data, we'll just insert data because it will automatically create the tables for us from the entities. Okay, so it's going to use our Java objects that we create to figure out what the schema should be. rather than us having to design both of those things. Next component, we have the DAOs, again, short for data access object. This defines the operations that you can do in terms of reading and writing to the database. Okay. And then at the top of that, that's kind of wrapped around all of that, we actually have the database object. And this is kind of a quote-unquote a holder, right? It's holding the actual SQLite database object. It's not the SQLite database object itself. So let's talk about entities. So as I've kind of said before, an entity really, an individual instance of an entity represents a row in a table. Okay, so it represents a row in a table. We're going to create those as POJO classes, or plain old Java objects. That's what POJO stands for, plain old Java objects. There's a similar acronym in C#. We just call them POCOs, P-O-C-O. Well, that just stands for plain old C# objects. So what that means is the class looks a little bit like this. It just has some instance variables, a constructor, and getters and setters. That's it. So basically, kind of like what we did yesterday, we created that word class, and then we just had it generate our constructor and our getters and setters. We'll basically do the same thing with all our entities. We'll define what properties they have and then generate the rest. One particular instance of this object represents a row, and then any member variables that we have on these entity objects are going to then represent the columns. So in this case, we've got a person table, which has 3 columns, has a UID column, a first name column, and a last name column. And if we were going to translate this to SQLite, this would be type integer, type text, if you remember our data types from yesterday. Now, remember that our tables need to have a primary key, so that's another thing we need to specify. That's one of the things that we need to specify in this, as well as there's some other things that we may need to specify as we're defining these entities, such as what is the name of the table, or what are the actual names of the column. If we leave this as is, without specifying those, it would assume the name of the table is person, as such, and first camel case name, last camel case name, but usually we're going to write the names of the columns with underscore between words instead of using camel case. So that's one of the things we may have to translate. The other thing that happens is oftentimes you'll have an existing maybe schema that was designed maybe previously for SQLite or some other database, and you want to keep the same table names and same column names. So, yes, you may, as far as asking whether or not the entity should be parsable, yeah, that's probably reasonable to make them parsable. The reality, however, though, with the live data and view model objects, making them parsable is actually not the best way to pass them around, actually. So rather than passing them around using parsable, which means we have to serialize them, or stringify them, we have to turn them into something we can save and then reload, we'll actually use view model and live data to pass things around when we talk about the second part of this, instead of making things parsable. So with live data and view model, you actually there's no reason to parcel to make any of your entities really implement the parsable interface as a general rule of thumb. You usually don't need that. Usually you can pass them around more efficiently without using parsable. So, talking about here. Okay, so I went through this mostly already. We've got our person class, we've got the UID, we've got the first name, last name. Here's how that table might look. So we've got our person table, and it's got a UID column, a first name column, a last name column, and you can see some sample data in there. So this would be one person object, and then this row here would also be a person object. in that table. So we do need to add some annotations to our class so the room knows how to translate them from POJO objects to tables and vice versa, from rows in the table back to POJO objects. So the first one we need to add up at the top is this entity annotation, and that just tells room that this class represents a row in a table, that it is an entity. Next thing we need to do is specify the primary key. So we'll do that by adding a primary key annotation to here, UID. So I'm going to say the UID is the primary key. And if I want that then to be an auto-generated, or sorry, an auto-incremented primary key, I'm going to say auto-generate is true. If auto-generate is true, then that's an auto-increment column. If I don't specify that or set it to false, which is false by default, then that primary key will not be automatically generated. It won't be an auto-increment. You'll have to specify the values in the code. So that sometimes is the way you want to do it. Sometimes you want to have it auto-increment. Sometimes you won't. The example that we're going to go through specifically today is actually going to use strings, or the word, as the primary key. So sometimes you'll have this secondary kind of arbitrary UID, sometimes you won't. It really depends on the specific case that you're working with. The next thing that we have on the first name and last name properties here, you'll see that we have a column info, name is first name is last name. So we're specifying what the name of the column is in the database, because otherwise it would be first name, no underscore, camel case the way that it is here exactly, but we want to say that it's first underscore name. So it's going to use that name for the column instead of the actual name of the field. Okay. The next thing we may want to do, we did add an entity annotation there. If we leave it just as is, no parameters to that entity annotation, it will just assume that the name of the table is the name of the class. So if we want to change that and we want to specify what the name of the table should be, then we're going to add in table name is blah. So this is going to mean that the table is stored as word table instead of the name of the class. So if it was like, for instance, the word class, by default it would assume that the name of the table is word. But here we specify that it's word underscore table is the name of the table. Primary keys. Again, you do need to specify a primary key because we need to know what column is the primary key. Auto-generate is going to determine whether you want that to be auto-increment or not. Another annotation we can add is to mark columns as non-null. Non-null says that you can't store null in that column. So if we don't specify non-null, then the general assumption is going to be that null can be stored. As a general rule, for all of your primary key should always have that non-null annotation to specify that you can't have nulls in your primary key. That's just a common kind of convention, is we don't use nulls for a primary key because that creates problems if we do. Talked about first name, so we can specify the name, the actual name of the column if we want it to be different than the field name. We can also specify some additional things in this column info attribute, or sorry, annotation, such as the name of the affinity, the affinity type, which we talked about yesterday in terms of SQLite. So I can specify that this should be a text column or an integer column or a real column, or how it should be stored. So that can be helpful to determine how you want it actually saved out. Most of the times it'll pick that up automatically. It'll kind of figure out what storage class should it be. It'll automatically figure out the data type from the data type of the variable. So say it's string, it's going to assume that that's a text variable. If it's an integer, it's going to assume that it's an integer. But there may be some cases where you want to specifically say what is it, especially if you're doing something maybe odd, or you're dealing with some legacy code. You might have to change the affinity. You can also specify in there for any sort of string column, text columns that you have. You can specify the collation, which will change how it's kind of sorted and compared. So for instance, you can set it to the collation to no case, which then means then anytime you're looking for that value, it will do a case insensitive lookup instead of a case sensitive lookup. So those are other things we can specify with the column info attribute. Okay. In order for Room to work, in order for Room to know about the columns and know about your fields, one of two things must be true. Either you make your field public, or you have a public getter for it. Okay, so what that means is there's kind of two ways to define your entities. You can either define all of your fields as public and then just skip the constructors and getters and setters entirely. That's a perfectly valid way to do things. Or you can say, okay, well, let's make the fields private, enforce some encapsulation, some access control on it, and then only have getters for some things and setters for certain things, etc. So it gives you a little bit more control on that front. But you do have to have a public way to get the value either way. Whether the field itself is public or the getter for it is public. If you don't have a public getter or the field is not public, then it will not create that as a column. It'll just kind of ignore it. So potentially you would lose that data, or you wouldn't be storing that data to the database. So that's something to keep in mind. There's two ways to build it. You can either build it with public fields, or you can build it with getters and setters. I'm going to go through it using getters and setters because that's kind of the norm convention. Okay. You can also use the relation attribute annotation to tie together related tables. So if you need to define, say, foreign keys you're going to do with the relation annotation. That's really out of the scope, though, of what we're going to look at here as far as 10.1 is concerned. So do know that you can define foreign keys, and you can use the relation annotation to do it here, but we won't really do all the examples that we're doing for 10.1 are really going to be just one table, which means that there's no foreign keys. So just be aware of that. A lot of times, especially on a mobile, in kind of a mobile space, foreign keys are something that you want to avoid for a lot of different reasons, mainly because there's an overhead in terms of managing those relationships, and they can cause errors when they get out of sync and such. So oftentimes we don't necessarily use a lot of foreign keys on a mobile device. Because there's a bit of slowdowns and different problems with them. You can look up more annotations if you go to the room package. There's a lot other annotations that you can use, and there's a lot more documentation about what some of those annotations do. Okay, so we've talked about entities, and the entities is what we're going to use to define our database schema. The next thing we need to talk about is our DEOs. So DEOs are going to define the operations that can be performed on that data. So whether that means writing data or whether it means querying or reading data, the DEO is going to define what those are. So specifically in the DEO, we're going to define all of the SQL queries that you can run against that data that are available. Okay. So any DAO that we create needs to be either an interface or an abstract class. All the examples that we do here will be interfaces. So in all of our examples, the DAO will be an interface. But you can potentially create that as an abstract class. The difference being there, if there's some logic that you want to be built in there that maybe relies on some of the methods that some of the SQL queries, maybe there's some additional processing you need to do. That's why you might make it an abstract class if you need methods that call other methods within that DAO for some reason. A lot of times you can potentially write that code also, rather than maybe making that code part of the DAO, you can potentially move it to the database as well. It really depends on what you're doing. If it's tied to a specific table, then you probably want to do it in the DAO. But if it crosses between multiple tables, it would make more sense to do it in the database object. So that's just something to keep in mind there. You can make them abstract classes, but for everything we do here, I think that interfaces will suffice. So Room's going to use these DAOs to kind of create a nice clean API for going between SQL and your code. It means by using these DAOs, most of your code won't have to know anything about the underlying SQL. It's only your DAO that will really know what those SQL statements are. So let's look at what an example DAO might look like. So we're going to start it as an interface. So at the top, we're going to define that here, public interface word DAO. That's the name of the interface. We typically end the name of that class with DAO, using that sort of capitalization. We also need to mark the DAO object with this annotation to say that it is a DAO object, and that enables some of the code generation that we need to happen in order for the translation to be there. So the next thing we're going to add in here, we've got an insert. We want to do some sort of insert statement. I've got a method here. It says void insert, and it takes a word. Notice that I don't have any sort of implementation for this method because remember, typically your interface method, the whole point of having an interface is you're defining kind of the signature of these methods, but you're not implementing them. Okay, so there's no implementation here for what happens, but we are defining what the signature for that method is. Now we've added the insert annotation on top of here, which means the Room is actually going to automatically take a look at that signature and figure out the necessary SQL to do an insert. So we say, okay, I'm going to give you a word object, and it goes ahead and figures out what SQL's needed to then insert that word into the database. Same thing here. We've got a statement to update words, update word objects. So we can say update words, and we take in an arbitrary number of words. Remember, the ... is basically like an array. It means that you can pass in one word, or you can pass in multiple words, or it can pass an array of words with that ... and it'll automatically figure out the SQL that needs to be written to take your word objects and run a SQL update on the table. So we don't have to write a SQL for either of these things, for the insert or the update. Now, what we're going to see on the next slide is some cases where we do need to write some SQL. We don't have to write all of the code for the methods, but we do have to tell it what the SQL is, the SQL statements for running those. So what we're going to see on the next slide is some cases where we've said, okay, run this SQL, and then it'll kind of automatically figure out how to translate the results and things like that. So here I've got a method to delete everything in a table. Okay, so I call it void. It's got no return, delete all. So that's my signature. So I want this method, if I call it, I want it to delete all of the records in that table. So what I've added to it is this query annotation. So the query annotation says, This is the SQL statement that I want you to run when the user calls this method. When the user calls delete all, run this against the database. So I'm saying delete from word table. Okay, so because I don't have a where clause on there, it's going to delete all of the rows from the word table. I think that there is a delete annotation, which you can use to just delete single rows. I haven't really played with that one to see how that one works. But if you want to delete multiple rows or delete all of the rows in the table, this is how you need to write it. There's not an easy, a simple annotation kind of shortcut for deleting multiple rows. The next thing we have is this select here. So I want to say, let's write a method that can get all of the words in the database. So we're going to return a list of words. We're going to call this method getAllWords, no parameters. And then the query here, you can see the SQL that it's then going to run. So it says select star from word table, order it by the word ascending. So it's going to go run that statement. That's going to give it back a cursor, and it's going to go loop through it and turn it into a list of words, kind of like what we did yesterday. But note that I don't have to write any of the body of that method like what we did yesterday, where I wrote that getAllWords method. I had to write all of the details and all that little nuance of even just to get those words from get all the records from the database. So here I just say, okay, this is what I want you to do. Here's your contract, here's your signature, and go run the SQL. So we'll go ahead and take the cursor and turn it into Word objects for me. I don't have to do that translation. Similar thing here, we're doing some kind of search. We're going to say find a word that kind of matches this pattern. So I'm saying select star from word table where the word is like word. So this colon word is going to get replaced by the value that you pass into the parameter. So this is kind of like a question mark with what we were doing yesterday, but it's named. Whereas with the question marks that we were looking at yesterday, that was like, well, the first question mark is the first argument, second question mark is the second argument, third question mark is the third argument. Here we're actually specifying those arguments by name. So then it will automatically take that and turn that into a list of words. Now, one thing I see here, I do see an error on the slide or two. So let me go in here. This should probably be an uppercase from. It doesn't have to be. SQL's not case sensitive, but usually we make keywords uppercase. And that shouldn't actually have an access modifier on it. Same thing with these. By convention, you don't put any access modifiers on your interface methods. They will automatically be public. So we've talked about how to set up our entities. We've talked about how to set up our DAOs, which are going to do the translation from SQL into our entity objects. And then we need to talk, so as far as the operations are concerned, and then we need to talk a little bit about the room database. So room, as I've mentioned before, is kind of a SQL object mapper. It'll kind of take your SQL objects, take SQL objects and your SQL statements and do the translation between SQL and Java. Do most of that translation before you. Okay, so it's going to work with those entities that we created to define the schema, as well as it's going to work with those DAOs where we're defining the operations that we're performing on that data. So to create a room database, we need to create a few things. So we've created an entity object, and we're going to create an entity object for each table in the database. We've created those DAOs. The DAOs, we're going to create a DAO for each type of data. But then to bring this all together, we're going to create a database object. Now, there's only going to be one database object in your entire application. You don't need more than one. You're always only going to have one database as far as things are concerned here. That class needs to be public and abstract. So we're not making a concrete implementation of the room database, which means that you can't say new room database because there's not going to be a concrete version of it. We need to annotate that class with the database annotation, and as part of that database annotation, we specify a few things. So the first thing we're going to do is specify the entities. So here we're specifying the entities that are used to represent the schema of that database. So in this case, I have a database that only has one table. It's Word. It's the Word class is my single entity, so I have Word.class. If I had another entity, another data type that would be stored in the database, I might also need to mention that here. So if I have 5 different tables, I need to specify all of those 5 tables here that are in the database. Next, we have the version number. So the version number is always going to start with 1. And that version number is very simple, similar to how the version number worked with the SQL Open helper. So we start with that version 1, and then every time we make a change to the schema, we're going to increment the version so that we can do basically a migration from one version of the schema to a next version of the schema. So say we need to add tables, remove tables, add columns, modify columns, any of those kind of things, we will do that we will increment the version number and then create a migration basically for that migration strategy. So there's the kind of the header of this room database class. Will be public abstract class. We give it a name. So here we're calling it the Word Room Database. I might just call this the Word Database. And we're going to say this extends Room Database. Okay. We're at 1:30. We're about an hour in. So let's go ahead and take a quick 15-minute break so you can stretch your legs, and then we'll finish up the last bit of this. So take a break, come back at 1:45, and we'll finish up the rest of these slides for today, and then go on to the practical example of this. Okay. Okay. All right, so far we started talking about the room database, and we've started talking about the different pieces that you need to make that work. So just to refresh real quick, you're going to create the entities for the entity classes first. Those are just going to be plain old Java objects, and those are going to define your schema for the database, and then you'll create DAOs, which are going to define the operations on that database. So you're typically going to have an entity for each table as well as a DAO for each table, but your whole app will only have one room database object, and that's going to tie all these things together. So the room database is going to be a subclass. Our database object is going to be a subclass of room database. You need to specify the entities. We're going to specify the version for schema change purposes. There we go. So here's maybe an example, at least the start of an example. Room database object. We need to define the DAOs that are available. So we're going to say word DAO. Have a method here that returns a word DAO. Note that it's abstract, so we don't actually implement that getter. You might call that word DAO as the kind of the name of the DAO. Also, oftentimes we'll sometimes call that get word DAO. Because really it is a getter. So you can call it either way. You can call it just word DAO, or you can call it get word DAO. I would usually call it get word DAO. I would say for that purpose. The name of the method doesn't particularly matter as far as room is concerned. Room just needs to know that it's returning this DAO object, and that DAO object has the DAO annotation. So it'll automatically figure out how to give you that or build that DAO. Okay. So that's the first part. You're going to have one of these getters for each DAO that your database has, or each table that your database has. And then the next thing we need to do is actually add a method that will kind of take this abstract class and turn it into a concrete class. Okay. So in the database object, and go back to full screen. So in the database object, we need to add some logic to actually build that concrete database implementation. So the way that we're going to do that is we're going to use the room.databaseBuilder method. So we give the database builder a few options, and then we call a few methods, and we're going to finally call build. Build is going to give us a final concrete implementation of this abstract class. So we don't have to write all of the code to implement this. It's going to kind of generate that code as needed. It's generally recommend that you only have one instance of this DB object once you've built it. You don't want to build it again or recreate it. And part of that has to do, a big reason for that is migrations. You don't want to have one database object that has one view of what the schema is, and another database object that has another view of what the schema is. So one of the things that they recommend here is maybe writing it as a singleton, using a singleton pattern. As a big rule of thumb, Singleton's not generally a good thing, regardless of what language you're writing it in, because there's a lot of issues there with static references and things like that, and not good. Really, singleton in general leads to really bad testability. So I wouldn't recommend doing a singleton here. Instead, what I'm going to do is I'm going to use the application object to ensure that there's only one instance, to make it such that there's only one instance that I'm using. So that's how I'm going to work around it. Rather than creating a singleton, which singletons are bad, especially in Android, I'm going to use the application object instead. Okay, so to build this database object, remember I said room.databaseBuilder. Well, what parameters do I need to pass to database builder? So the first thing I need to pass to the database builder is a context. Okay, generally that context is going to be your application. It should really always be your application. Okay, so you've got your application, and then the second thing you need to pass in is the class. So this is Word database class. So they're going to say, okay, we'll use this class, this kind of abstract class to build it. And then the third argument is the name of the file. So this is going to create a Word database file in internal storage. That's where it's actually going to save the SQLite database. Okay, so that's what we need to give it to get started. Okay, so we're going to create the date. We're going to say, give me the database builder, and then finally build. Okay, now what else do we need to do in between? Okay, we may also need to call add callback. So add callback is going to add in this callback object, which we'll look at in a few slides, which allows us to respond to certain events as the database is getting set up. And the main reason that we need that is to set up initial data that we want to be there all the time, as well as just other things that we may want to tweak about the schema, or things that we may want to change about the schema that's different than the way it generates from room. So if we want to override some of its decision, we would do that. So that callback we'll look at in a minute, but that gives us a way to inject and run code on when the database is initially created, when it's upgraded, as well as anytime it's opened. Okay. And then the last thing we need to do is specify a migration strategy. So here we're calling fallback to destructive migration. Okay. This is not the method you want to call ever in production grade code. So fallback to destructive migration says that if something changes about the database schema, just delete the entire database and start over. That you don't want to do in a real world app, because you're definitely that means that you lose all of the user's data if you just change one column. In your database, you add one, you remove one. If you make any change to your schema, the user loses all their data. So this is not something that you want to do in a real world application. We're going to use it in our example projects here, because we're just trying to kind of do this in more of a test environment. It's going to make it easier to kind of debug and not have to worry with migrations, not worry about migrating the schema as we're testing it, but recognize that if you were going to put this in a production, an actual released project, you probably don't want to fall back to destructive migration unless the data that you're storing in the database is purely a cache, right? So if that data is not actually created by the user, it's just a offline cache of stuff that's already available online, that's okay. And to some extent, that is a very common case for using Room and using SQLite, is that you're just caching for offline access some of the data that's already available online. But if you're storing users' data, user-created data, you definitely don't want to do this if any of your data was created by the user or owned by the user. Okay, so the way that kind of plays out, typically inside of our database, our room database subclass, we're going to create a static method that returns a public static method that returns our database object. Here I'm going to call this build database. It's going to take in an application object, and that's our context. And then we're going to call all those methods that we saw previously. So database builder, we need to pass in the context, the database class, Word database as the name of the database file, and then just run through here and return that. So this method we're going to add to our database class, and that will allow us to actually take the abstract class and turn it into something that will now read and write data to the database. Now, you'll notice that this callback is in here. I kind of briefly mentioned that on a slide before. But where is that callback object actually located? So that callback object needs to be located the same place that this build database is. Okay, and because this build database method is static, realistically it also needs to be static. Okay, so an example of what that might look like is you're going to say private static. I'm going to make a little instance variable here, and in reality this can probably be, I think this can always be private static final, and probably should be, because I want to create that callback once and I don't want to change the callback that I'm using there. So that will be basically quote unquote a constant. It's not kind of the constant in the typical sense. So I'm going to create this callback object. Okay, so I'm going to implement the room database.callback interface and create an anonymous object here. So this would probably, generally this would be right underneath our build database method, would be this callback. And I'm going to say, well, I need to implement whatever methods are relevant to me. So I can override onCreate. Any logic that I put in onCreate will happen the first time when the database is initially created. So that's a one-time thing. I can also put in an onUpgrade. OnUpgrade is going to be anytime there's a change in the version number. So let's say we go from 1 to 2 or 2 to 3. That's where onUpgrade is going to get called if there's a change in the version number. And I can also put it into a method called onOpen. Now onOpen runs anytime you open the database, which for our respects, when we open the database is going to be when the application starts. So that means anytime your application starts, it's going to run onOpen. So onCreate's only going to get run once. OnOpen is going to be called every time you every time you run the application. So what that means is, if we want to say put in data, initial data that we want to be there, initially when the user installs and starts running the app, we'll put that in the onCreate callback. But if we need it to, if we say, well, we want to do this every time the application starts, then I would put that in onOpen. So onCreate is a one-time thing. OnOpen is every time the application starts. Okay, and both of those take this support SQLite database, this DB object. And the upside of that is on this DB object, we can call that exec SQL method, just like we did yesterday. So we can run any sort of SQL statements that we need against that DB object. Okay. So there's a few things that we want to pay attention to on Room, or good things to know about. There are a lot of compile time checks for our SQLite statements. So you remember, if we go back to our DAOs, we had to write some SQL statements in those annotations, specifically in the query annotation. It will go ahead and at compile time figure out if those are valid SQL. Which is nice, because the old way of doing this with like the SQL Open Helper, we didn't know if our SQL was invalid or valid until the application actually ran, which meant that it was a runtime error and meant that Oftentimes we wouldn't catch the error until it was maybe in a user's hand, versus this allows us to see those errors a lot sooner. The other thing we want to do is we don't ever want to run database operations on the main thread. That's always a bad idea. Running database operations on the main thread is always a bad idea, regardless of if you're using Room or the SQLite Open Helper or anything, because they can be long running. So on the other hand, where the SQL Open Helper does not throw exceptions, if you try to access the database on the main thread, it will just say, okay, I'll go do that. And if it takes too long, then you'll get Android not responding dialog pop up and say, hey, do you want to keep letting this go? Room, on the other hand, if you try to run any sort of database operation on the main thread, it will go ahead and throw an exception and say, no, you can't do this. You should move this onto a background thread. So what that means in practice is that if we're going to do any sort of select, insert, update, delete, any of those sort of statements against the database, we need to do those in a background thread, whether that be through using a thread object itself directly, or using an async task, which the examples that we'll go through here are all using async task to run those background operations against the database. The other thing that we can use is this live data object, which we will talk about next week. And that can actually do some of the queries in an asynchronous kind of fashion on the background thread. So if we're using live data, we don't have to write as many async tasks. But what we do today, we're gonna skip live data for the example, and we're going to do it entirely with async tasks. So you can see what's kind of going on underneath the surface, because especially when you put live data in there, it can be a little bit maybe not obvious about what's going on, about what kind of things actually need to be run on the background thread. So that's part of why I want to go through the example before we touch live data, so you can see what that actually means to run things on the background thread, because you will need to do, even with live data, you will need to do some things on the background thread. Okay. We want to make sure that we use an application subclass to instantiate and hold that Room database object. So the recommendation, if you read through the reading or the original slides here, they said, hey, use a singleton. But really a singleton is I would say not recommended. The better way to do it is have the application object, your application subclass, have that instantiate and then hold the Room database object. So what that means is, again, the application, its onCreate gets to run before anything else runs. So it's going to get a chance to set up that database before anybody else gets a hold of it. And that also makes it just easier to manage in terms of when things happen. Okay. So the last piece on the slides I want to talk about before we go to our example is this idea of a repository. So a repository is it's not really part of the architecture components. You can use all of these architecture components without a repository. But the idea of this repository pattern is it kind of provides a joining point for the different ways of getting the data. So behind the repository is how you actually go and get the data. The repository just says, hey, here's the data. So behind that, you can kind of think, the way you can kind of think about the repository is it's used to fetch data in the background. It deals with those parts. You can kind of think about the repository as being that chef. If you're working in a restaurant, the chef prepares the meal behind the scenes, and then eventually it shows up at your table. So the repository, that's kind of their job, is to make sure that the things happen on the background threads that you need to happen on the background thread. And that way the UI doesn't have to know all the details, all the nitty gritty of where did the data come from, how is those background thread managed, how are those background threads managed. That's kind of hidden away in the repository for the most part. So the place that really becomes useful, introducing that repository pattern, is if you have more than one backend. So if I say, well, sometimes I want to retrieve this data from the data access object, and sometimes I want to retrieve it from the network. So if we're thinking about the NPR Technologies kind of application, I might say, well, if I don't have any data in the database, well, I definitely need to go out the network to get it. But ideally, I'd like to, most of the time, go to my local database to grab those articles. So originally, when I go retrieve the articles, I'll go grab them from the internet, and then I'll save them into my database. So then from there on, I can access those articles whether I'm online or offline. I can get those out of the database. Eventually that's going to get stale, so I want to keep some information in the database to know when those were retrieved. So I might say, well, let's go look at what's in the DAO. If it's an hour old and I have a network access, well, then let's go grab the newest version from the network and save that to our database. But if for whatever reason I don't have a network connection, or maybe I just grabbed that data from the internet just a few minutes ago, it probably hasn't changed since then. So I'm going to go to the DAO and just say, give me that version that I just got already, rather than making every trip for that data out to the internet. So how this might look with a repository, internal to that repository, I'm going to have the database object, and it's also might have access to the DAOs. And then I'll add methods in here that will then allow me to get to those things. And it'll determine, well, do we need to pull it from the internet? I'm going to use an internet source? Am I going to use a local database source? So I might expose things like a getAllWords method that returns a list of words. And that would call into the DAO. Or I could have, say, a getAllArticles, and that would say, well, is there network connectivity? Well, then let's go get it from the internet. If there's not network connectivity, let's get it from the DAO. Those kind of things. I also have an insert method here, which is going to call into the DAO to insert a word. So I call that, and you note that there's an asynchronous task here to go ahead and execute the insert on a background thread. So this repository is kind of hiding the fact that this insert is actually happening on the background thread. The user of the repository doesn't know that the insert is happening on a back thread. So it just says insert, and then assume it went through successfully. Okay. So for instance, to offload that to a background thread, I might create a task like this. Say insert async task. This extends the async task. You'll see that I have those 3 different type arguments. So the first one, remember, which is word here, is the input parameters, which are the things that we pass into the execute method as well as the do in background method. We have the progress, so there's no progress, and then we also have the result. So here there's no result and no progress event. We just say, okay, go do it, take a word, insert it into the database, and be done. Now, I have set this example here I have set up so I could actually implement insert more than one word with this task. So for instance, remember the ... that's basically equivalent to an array. So I'm getting an array of words. I loop through that array and insert each word, and then finally I say return null to get out of here. So that's how that might be implemented as far as the repository goes. Okay. Again, that repository will make more sense when we come back and say, well, what if we want to sometimes pull it from the internet, sometimes pull it from the database? That's really a topic for next week. But this week we're going to focus purely on just okay, I'm always going to pull it from the database. So I'm going to skip the repository, at least for the example that we're going to do today. Any questions? Okay, so we're going to take a quick break here. If you haven't yet, please pull down that finished project and get it up and running. Give it a just try it out, the example project that I put on Discord. Give that a try, and then when we come back, let's call it 225, we'll start another stream and we'll go through a practical example of starting to work through the lab for 10.1. Kind of seeing how some of these things fit together to use a database. So what I've included in Discord is the finished project. Go ahead and pull it down, play around with it so you can see where we're going. But we're going to start that from scratch. We're going to start that as a brand new project. So just keep that in mind. That's the expectation, is we want to start from scratch and build up to there and talk about all the pieces in between. Okay, so let's take a 15-minute break. I'll switch things over. We'll start a new stream, and I'll see you at 2:25.